Okay, welcome back to a new math tutorial. In this video, I would like to explain how you can apply the most fundamental operations on complex numbers. So we will start with a very easy problem, which is just a sum of two complex numbers. And as you might know, a complex number always has a real part, which is in this case, for example, a 5, and an imaginary part, which is here in this case a 4, which is multiplied with this imaginary unit I. And we want to, after summing up these two complex numbers, we want to get a new complex number, which has again a real part and an imaginary part. And this is the simplification that we want to do. And the same we will also apply in part B, but here we will replace the plus sign with a minus sign, which means we calculate now the difference between two complex numbers. And later you will see that it's exactly the same, only a few things are changing. However, both is very easy. The real tricky part starts when it comes to the multiplication of two complex numbers, because here you have to take care especially of the sign which you get when you multiply two i's with each other, two imaginary units. And then the most difficult part is actually the fraction of two complex numbers. And again, I want to have at the end a complex number where you have a real part and an imaginary part. So now we will start with part A. So I would like to create a new page for that. We can directly dive into the topic. So I will just copy and paste what was written down in the exercise. So we have 5 plus 4i plus 3 plus 2i, and of course, because we have just a sum, we can completely ignore these brackets. So this would be the same as if we write 5 plus 4i plus 3 plus 2i, and now we have to sum up each part individually. So we can sum up 5 plus 3, which would give an 8, and then we have here two numbers, 4 and 2, which are multiplied with an imaginary unit. And this I can be just treated as a constant multiplied with a number. So we can write now here 4i plus 2i, which would be in this case 6i. So this is very simple. As I said, we just have we directly get a new complex number, which has a real part and an imaginary part. So we cannot simplify this further. And the final result is here. I would like to write it down here also. 8 plus 6i. So this was simple. We can, before I would come to the second part, we can also write down a formula. So when we have, for example, two complex numbers, z1 and z2, and we add them up, so we can replace z1 with x1 plus I y1, just variables that we insert here, plus z2, which we replace with x2 plus I y2. So we get here the sum of x1 and x2, which is x1 plus x2. And then we can factorize this I. So we can write I times y1 plus y2. Also very simple. So you have a formula now, which I think you don't need, because just summing up the numbers is usually easier than applying this formula here, but now you have it also in a more general form. And now we can also directly calculate part B, which is the difference between these two complex numbers, 5 plus 4i minus 3 plus 2i. As you can see, I always have chosen the same numbers. So always 5 plus 4i for one of these complex numbers and 3 plus 2i for the other one. So it's easy. Now this changes now to 5 plus 4i, because here we can remove this bracket again. Here, however, we have to keep these brackets, of course, because this is a multiplication with -1. So here we have to write minus 3 minus 2i. And now we have to do the same what we have done here before. We have to calculate 5 minus 3, which is, sorry, not 2i, but just 2. And then we have to calculate 4i minus 2i, which is 2i. So we can write here plus 2i. And again, this is the result. So we can write now here, the result is 2 plus 2i. Now, this was actually, again, very simple. But now we come to the more complicated part, and this is the product of two complex numbers. So again, I would like to create a new page. Now we can write 5 plus 4i times 3 plus 2i. So the same what we have to do when we calculate the product of two sums, we have to calculate, or we have to multiply each part of that sum individually. So 5 times 3 we have to calculate, which is actually a 15. Then we have to calculate 4i times 3, which is 12i. Then we have to calculate 2i times 5, which would give 10i. And then we also have to multiply our 4i with 2i. And here it gets a little bit tricky, because when we calculate I times I, which is actually the same as I square, then this is the same as the square root of -1 squared. And the square root of -1 squared is just simply -1. So I times I is -1 times 8 gives -8. So this is the only thing where you have to take care when you calculate the product of two complex numbers. The rest is just simply straightforward. So now we can calculate 15 minus 8, which is simply 7. And we can calculate 12i plus 10i, which is 22i. Okay, and this is already the result. So we can write down here 7 plus 22i. Before we come to the fraction, I would also like, similar to what we have done before, I would like to write it down in a more general way. So if we have the product of two complex numbers, z1 and z2, which can be again written as x1 plus I y1 times x2 plus I y2, then we have to multiply again x1 with x2, which is an x1 x2. Then we have to calculate I y1 times I y2, which gives a minus y1 y2, similar to what I have explained here. And then these two parts with this imaginary unit remain, which we can again factorize. So we can write I times and then x1 y2 plus x2 y1. Now when you do this calculation, you find out that this is actually the only way how to write it down. And again, now we get a formula which you can use for the multiplication of two complex numbers, but again, I would not use that. I would directly apply this math, which is much easier. And now, as I promised before, we come now to the most complicated part, which is actually the fraction of two complex numbers. So now again, I would like to create a new page and write down 5 plus 4i divided by 3 plus 2i. This is a little bit tricky. Similar to what we have done before, we want to get one complex number with a real part and an imaginary part, which means we have to get rid of this denominator. And we are doing this by using a trick, actually. So there is something when it comes to complex numbers, which is called complex conjugate. So we actually want to do some complex conjugation with a complex number. So if any complex number is given as x plus iy, in the most general way, you can write it down like that, then the complex conjugated, which is normally denoted with a bar, some people also use star, but I think this bar is actually the more common one. So z bar is then given as x minus i1. This is the complex conjugated form. Of course, if there is a minus sign here already written, then you have to replace it with a plus and so on. But I think the idea behind this is quite simple. The advantage of writing it down in such a way is that the product of z and z bar, so the product of a complex number and its complex conjugated form, is simply x plus iy times x minus iy. And as we have seen before, when you now apply the rule of multiplication, you find out that what remains is actually x square plus y square. So what we get out from this is the absolute value of z, if you consider this to be a vector, for example, and these are the two components, then we get the absolute value of z squared. And this makes it then quite easy. So what we have to do now here, we have to multiply this fraction here with the complex conjugated 3 minus 2i, this is the complex conjugated one, divided by 3 minus 2i. So we do not change the value of this fraction by multiplying the numerator and the denominator both with the same value. And then we can write it down in the following: 5 plus 4i times 3 minus 2i divided by 3 plus 2i times 3 minus 2i. Yeah, and then, as I said, the I in the denominator vanishes, because here we get a 3 square plus 2 square. Yeah. And in the numerator we get, again, when we apply the rules of multiplication, this I can write down now simply, easily, 15 plus 12i minus 10i plus 8. Okay, so the only thing which we have to do now is using the laws of addition that we have used before, and we have to calculate 15 plus 8, which is actually 23, and 12i minus 10i is 2i, divided by 9 plus 4, which gives 13. And then the only thing which we have to do, we have to divide the numerator by the denominator, which gives a 23 divided by 13 plus 2 divided by 13i. So again, what we get here at the end is a real value here and the imaginary value, which is multiplied with I. So we get again a simple complex number, and we cannot simplify this any further. Yeah, there's no possibility. The only thing which we could do is maybe replacing this fraction with decimal. But I think in this case, if you write it like this, it's more elegant and the exact answer actually. So the only thing which we have to do now, we have to add this into our problem sheet here as a solution. 23 divided by 13 plus 3 divided by 13 times I. Yeah, and this is the solution of our problem sheet. So as you can see, it's quite simple. Nothing is really complicated. You only have to concentrate a little bit to make sure that all the i's are multiplied in the correct way, and you take care of the plus and minus signs, but the rest is just straightforward, just similar to what you have learned already in the case of real numbers, rational numbers, and so on. Yeah, and if you understand this, then I think you are very, you understand almost everything which you need in order to do calculations with complex numbers. There is, of course, much more which you can do with that, especially when it comes to rotations and e to the power I and so on, which will be not part of this video, which I can explain in another video. The fundamental operations you understand now. And yeah, this is everything what I also want to explain now in this video. If you like the video, I would be really happy if you hit the like button. If you want to see more of that kind, please write it into the comment section. Otherwise I would be really happy if you subscribe my channel if you have not done so far, not only to not miss further videos, but also to help me to let my channel grow a little bit. And otherwise, see you very soon for a new video.